Good morning, I'm Devasena. In this lecture, we are going to discuss about evolution of the radio topic. This topic is the fundamental topic that is available in the communication department. Radio. Radio is a way news and information can reach the widest audience in the world. The invention of the radio changed that forever. In the early part of 20th century, experiments with wireless radio were taking off, and soon news from around the world was reaching the homes of millions in an instant. Evolution of radio. In 1895, a young Italian named Guglielmo Marconi invented what he called the wireless telegraph. He used radio waves to transmit Morse code, and the instrument he used became known as the radio. Guglielmo Marconi. Guglielmo Marconi, an Italian inventor, proved the feasibility of radio communication. Is Guglielmo Marconi. He sent and received his first radio signal in Italy in 1895. Creation of radio. Radio started life as wireless telegraphy, and it was designed for communication rather than music and entertainment. Marconi both sent and received his first radio signals in 1895, and he was also the first to send messages across the ocean. In 1910, Marconi established the American European Radio Telegraph Service. Let us see the various representations of radios. Further, we will discuss about how the radio functions in the other slides. Vacuum tube radios. Before the transistor was invented, radios used vacuum tubes. Here is a representation of vacuum tube radios. Although portable vacuum tube radios were produced, they were typically bulky and heavy. The need for a low voltage, high current source to power the filaments of the tubes and high voltage for the anode potential typically required two batteries. Vacuum tubes were also inefficient and fragile compared to transistors and had a limited lifetime. Let us see the parts of radio. Here is a representation of a radio and its parts. The radio, mainly we are having a tuning knobs, headphones and other components that are indicated in the diagram. Transistor radio and its parts are represented here. This is the radio that uses transistor, and here the parts of the transistor radio. Will be having a volume control, audio transformers, tuning capacitor, long wave, medium wave switch, ferrite antennas, IF transformers, transistors, loudspeaker, earphone jack, battery compartment. Walkman radio and its parts. This is the representation of a Walkman radio, and here are the parts of the Walkman radio. Let us see the flow process of radio representation. Here is a representation of a flow process that takes place in the radio. The original sound is being converted into an electromagnetic signal with the help of the microphone, and that is being encoded with the help of an decoder that is being transmitted with the help of transmitting antenna. The signal is being frequency modulated or amplitude modulated, and then it is being transmitted through the transmitting antenna. In the receiving antenna, we have three parts. One is the tuning part that is being done by the tuning oscillator, then decoder, because the encoded information has to be decoded in the receiving side, and we have an audio amplifier. This setup is connected to the loudspeaker in order to reproduce the original sound. And this is the flow process that takes place in the radio station. Transmission antenna. In a radio transmission, a radiating antenna is used to convert a time-varying electric current into an electromagnetic wave or field. Here is a representation of the transmission antenna. This propagates through a non-conducting medium such as air or space. In a broadcast radio channel, an omnidirectional antenna radiates a transmitted signal over a wide surface area. In a point-to-point radio channel, a directional transmitting antenna is used to focus the wave into a narrow beam which is directed towards a single receiver site. Here is a representation of the transmitting radio waves. The sound waves are converted into the electromagnetic wave with the help of a microphone. The electromagnetic wave is then modulated by adding a carrier wave along with the original wave that is being amplified, and it is being broadcasted through the broadcasting antenna. This process is represented here. Propagation path between the transmitting antenna and the receiving antenna is represented here. In between the transmitting antenna and the receiving antenna, we have an electromagnetic wave that is being represented here. Reception antenna. Here is a representation of a reception antenna. The transmitted electromagnetic wave is to be received in the receiving side with the help of reception antenna. The received signal is then decoded and demodulated with the help of decoder and demodulator circuit. The original sound is reproduced in the receiver side through the loudspeaker. Receiving radio waves representation is shown here. The receiving antenna receives the electromagnetic wave that is being transmitted from the transmitter side. With the help of decoder, demodulator, the electromagnetic wave is converted into the original sound wave, and that is the audio frequency wave. With the help of the audio frequency amplifier, it is being amplified and it is being passed to the loudspeaker in order to reproduce the original sound that is being produced in the transmitting side. This process is indicated here. Tuner function in radio. Here is a representation of a radio wave. In between the transmitter antenna and the receiver antenna, we have an electromagnetic wave. For each and every radio station, we have an unique frequency. That frequency has to be received in the radio. That is done with the help of a tuner circuit. Here is a tuning knob that is available in the radio. The purpose of the tuner is to tune the radio for receiving the program that is being broadcasted by the radio station. Tuner function we will discuss now. Variable capacitors are used with inductive coils in tuning circuits of radios, television sets, and a number of other devices. that must isolate electromagnetic isolation of selected frequencies. Tuner circuit representation. A simple crystal radio can receive AM radio signals and convert them into sound. Here is a representation of a tuning circuit. In the tuning circuit, we have a tank circuit that comprises of inductors and capacitor. Radio waves of all three stations come in contact with radio receiver antenna. The antenna converts the radio signals to alternating current, which is conducted up and down the antenna to the ground. The antenna is coupled to the tank circuit by mutual induction. AM radio. AM broadcasting is radio broadcasting using amplitude modulation transmissions. It was the first method developed for making audio radio transmissions. It is still used worldwide, primarily for medium wave, also known as AM band transmissions, but also on the long wave and short wave radio bands. FM radio. FM broadcasting is a method of radio broadcasting using frequency modulation. Invented in 1933 by American engineer Edwin Armstrong, wideband FM is used worldwide to provide high fidelity sound over broadcast radio. FM broadcasting is capable of higher fidelity, that is, more accurate reproduction of the original program sound than other broadcasting technologies such as AM broadcasting. Signal, AM signal, FM signal representation. AM, that is amplitude modulation, and FM, that is frequency modulation, or types of modulation, that is coding. Here is a representation of a signal, amplitude modulated signal and frequency modulated signal. The electrical signal from program material, usually coming from a studio, is mixed with a carrier wave of a specific frequency, then broadcast. In case of AM, this mixing, that is the modulation, is done by altering the amplitude, that is the strength of the carrier wave proportional to the original signal. In contrast, in the case of FM, it is the carrier wave's frequency that is varied. AM/FM waveforms representation. Here is a representation of the amplitude modulated wave. Here, the carrier wave is mixed with the audio signal. The amplitude of the audio signal is varied in order to obtain amplitude modulated wave. Here is a representation of the frequency modulated wave. That is, the audio signal is mixed with the carrier wave. In this, the frequency of the audio signal is varied. That is represented here. That is the frequency modulated wave representation is shown here. Reason for using frequency modulation for audio transmission, because the frequency of a radio wave is less vulnerable to noise than the amplitude part. FM was originally introduced to reduce noise and improve the quality of radio reception. FM, though, because of its relative noise-free reception, is used to transmit the audio part of the television signal. FM radio in mobiles and smartphones. Due to the ASIC technology, this FM radio portion is nowadays available in all the mobiles. From the 2G it is being available. The FM radio app is available. Here is a representation of the FM radio that is supported by the 2G mobile phone. Here is another representation of the FM radio that has been incorporated in the smartphone also.
Thank you very much for listening this lecture. If you like this lecture means kindly share this video to your friends and kindly subscribe this channel.